Okay, so welcome back. So we are going to continue our discussion for chapter 6. The first couple of sections is about a package and package private. Last lecture, I already discussed the concepts. So in this lecture, let's take a look at the example. Okay. And the example in our textbook, it's Java inheritance example to animal. Okay. And for this example, majority of the parts are similar as the previous example for the animal, the first example. But here we design package. Okay. So if you take a close look, you will see we have an animal package. We also have a client package. So we have two packages in this example. For the animal package, we have those three animal class, animal, pet, and wildlife. We have those three related files, related classes. We group them together under animal package. For the driver, we just put it under the client package. Okay. So let's see how do we, so we organize our file as a package like this. So how do we reflect it in our coding? Okay. So let's first take a look at the animal class. So this time the animal class is in the package animal package. So in order to have the package for this class included in the in the package, you need to have this statement package and the package name animal. Okay. And then within it, we define this class. And this class is public accessible. Okay, so everyone can access it. But if you take a closer look, you will see. So here are these three instance variable. Before that, we don't have, so no visibility modifier. In our previous example one, it's protected. So now no, okay. And if you record, because it's in package, so they are considered as a package private. Package private is just then pet and wildlife, they can also access, okay. So accessible by pet and wildlife. It's not through inheritance because package private, okay? But you see for the count, we still define it as a class and a variable and only accessible through animal class, okay? And for the constructor, so let's take a look. Okay, let me erase all this. So constructor, if you take a look, there is no difference, okay? And this second constructor, explicit value constructor, also no difference. But if we take a look, all the three accessors, now they are package private. Okay, so it's not protected. Okay, so they only available within the package. So of course, the subclass can still access because subclass are put within the same package. So that's a change. And for the count of animal, it's still public class method. And for set method, For mutator, same thing. We put them as package private. So no protected or public or private modify anymore, okay? And for this eat method, we didn't change. So it's still public, so anyone can access, okay? Get clone, same thing, it's still public. And the toString method and the equal method still override the object root class and still public available. And we also, we made some change. Okay, so here we have some change for superclass. We add the get maximum speed and set maximum speed method. And both of them, they are public method. So everyone can access. Uh, uh, I forgot let's go back check, okay. The maximum speed, maximum speed, it's not the newly added. So these two methods, nothing changed from example 1, okay. So no change. No change, okay. For this train method we add, okay, this newly added, the train method. So the train method, what it does is, it's just call the set maximum speed method, and it's public, so anyone can access. So it's keep increasing the maximum speed, okay, through some numbers that you pass in through the parameter. And this method is also public method. So this is our change to superclass. Superclass. So we add a new method, okay? And if you recall, in the concept section when we discuss, this may have secure hold. Okay, so let's take a look. And then how we handle that. So that's animal class. And then let's take a look at the pet class. Pet class, because we also group them in the animal package. So you needed to start this file with the package animal, okay? And it's still a subclass of animal, so nothing changed. And this part, no change, and constructor doesn't change. And if you, let's see, yeah, then here we change, like the accessors, they are changed to package private. Okay, no visibility modifier. And the get number is still as a public class method. And the set method, same thing, it's mutator, and we change it to package private, okay? And we override the eat method. So this is same. ToString equals the same, no change. Okay, and okay, and over here, okay, over here, we did provide the override train method from superclass. Okay. And for this method, it also check because it's for the pet, uh, because pet is mostly at home, is it? And so normally you don't want to overwhelm them, okay, with too much training, is it? So uh, normally, uh, normally before you do some intensive training for pet, is it to increase its maximum speed? You want to check, okay, if the intensity is too much, is it? So that's we also provide this utility function as a private only in the pet class to check, okay, if the pet can tolerate more training, okay. And if it is, then you go ahead to train it through that call of set maximum speed. So this is the, we override this method, the train method from the animal class. Okay, that's about the pet class. Then let's take a look at the wildlife class. The wildlife still it belong to the animal package, so you needed to start with this statement to package animal. Okay, and the habitat and the constructor looks like they don't change. Okay. Let's see anything else. The get methods, they change it to package private, and the set habitat change it to package private, and the eat method not change to string and equal nothing change. And there is, and the wildlife, we didn't override the train method. And now let's take a look at the driver. Okay. So for this driver file, the driver file, it's in the client package. Okay. So we start with this package statement. And because we are going to use that animal package, is it? So you just do the animal, you import this animal because we are going to use all three of the classes. We don't need to import each individual one. Is it? So you just use the wild card to indicate that any of the class within this package that can go ahead be used directly. Okay. Okay, so then for the hippo, the static type is animal, and the dynamic type is also animal. So it matches. So it's the same as in the example one. You can check. And then here we call the clone. So it will, so this is a deep copy again. Okay, and the hyperclone, the static type is animal, and the dynamic class is animal, so the matches, so everything is okay, okay. And then you can check, is it? So that's fine. And this time, you see, for the clone, you try to call the set method, set name. In the example one, this is allowed. But if I comment out this, and you will see there is an error. It says it's not visible. Is it? Why? Why it's not visible? It's because if we go back to take a look at the animal class, animal that's set name, is it? Set name. Set name. Okay, the set name is here. Set name. And here we see the because it doesn't have the visibility modifier, private, protect, or public, is it? And this is defined in animal package. animal package. So it's a package private, only accessible within animal package. But now, over here, you try to access it, try to access through client package. That's why it reports errors. That's invisible, is it? So that's not allowed, okay? So this gives us the idea of the information hiding, okay, and or encapsulation for package level, okay. So this did show. Okay, then next, let's see. So fluffers, it's PAT. So it has the eat method and it's also public. So that's why you can go ahead to call it. And the wildlife, okay. And the constructor, they are public. Always need to be public, otherwise you cannot create objects, okay, unless you have some restriction for your design. And the get count is class method, so in animal class and public available. So yeah, so you can do that. Get number, get out. So this is same as in example one, okay? And the first while you call the get class method, we will see, okay? And it will show, yeah, it's class. And this time, but if you take a look, it's not just a wildlife, it also gives you animal dot because this wildlife belongs to animal class, okay? So it indicates, it also tells you the class or package. So it's a package and then dot class name. Okay. Okay, then let's see. So here we create an animal array and it's initiated with hippo and fluffer. Okay, so hippo is animal, fluffer is pet. Okay, and then within the loop, so here is for each loop. For this, for each loop, you call the train. Okay, so for this train method, it's so for hippo, it will call its train, and for the second one, so for ARR sub-zero, that will the train method is going to be from animal class. Okay, for this ARR1, then the train method should be from pet class. Okay, so even though you declare the array as animal, yeah, because this is, if you recall, this is static type, and this is a dynamic class. Dynamic class, is it? And here, the train method, then it involves polymorphism. Morphism, okay. For morphism, then it's implemented to will find which version is it, which one's train is going to be called. It's through that dynamic dispatch. The dynamic dispatch will go ahead to check the virtual table. And in the virtual table, it find the furthest method that qualify, as it. So here is qualified. It will call paths. But if you see, if we call the paths, okay, call the paths, then let's go back. The good thing is just think about it, is it? So the pattern, we override this train method. If we don't override, suppose you comment, you can try it, okay, after our lecture. If you comment out of this train, comment out. So, and also this one, comment out. So if we don't provide, if we don't provide what it does, the train method, then it will go ahead to call the train method. Call the train method from superclass, from animal class. Okay, then it will just go ahead directly set the maximum speed. It doesn't care about the intensity for the pet, is it? So suppose the pet is a poodle, okay, at home, and you wanted to train it to run 100 miles per hour, something like that. Is it? Will that overwhelm the poodle? Yeah, for sure. So that will be an issue, is it? But here, the good thing is we provide our own, the pet has its own train, and it will only allow the train to happen if the training intensity is still within the pet's tolerable level. Okay, then it will allow because we provide this override method. So we avoid the security hole for not to provide the train method in subclass. Okay, so that's regarding the train method. But let's take a look. So let's take a look at the driver, okay, and the driver also, over here it's set maximum speed, is it? For this set maximum speed, and for poodle, for ARR1, is it? It's a fluffer. Fluffer is pet. So even though the train will be avoid in this case, is it? But you see, this set maximum speed will still overloaded the fluffer. So fluffer may not, so fluffer cannot tolerate this training. Okay, you see, the set maximum speed, is it? So it cannot, it's far beyond what fluffer, the pet, can tolerate. And why? Because if we go back to take a look, the set maximum speed, because set maximum speed, it's in animal class. but it's not provided in PET class. Okay. So set maxima not overridden in PET class. So that's why here the fluffer get exposed for the security hole. So this is a security hole, is it? Because when we design the PET class, you see, we know the fluffer PET cannot tolerate. Then for this kind of method, then you do need to be careful with it. Yeah. So try to avoid the security hole. Okay. Okay, and let's see what other method here. What else we did? Okay. So here, the idea is to achieve the secure coding good practice. Then in this case, we either override override the method in subclass, or we set the method in superclass as package private. Don't set it as public. Okay. So then in this case, no attacker can take advantage of this security hole. Okay. So we can take a look, go back to animal class. Okay. And you see, if you get rid of this set maxima, expose as public, then over here, it will not allow you to do this, is it? So if you do provide it as public, then what we need to do is we need to do the same thing as the train method. So for the train method, then in our subclass design that we override this train method. When we override, we do the security guard. Secured guard. So we add, and we also provide this as a private method, exclusively only for the PET class. And then in this case, you see, if the intensity is greater than what it can tolerate, then you will not let it to do the training. Okay. Yeah. So this shows how we achieve the goal for secured coding when we consider superclass and subclass inheritance relationship. Okay, so that's the example discussion so that we can have a real understanding about the package private and the inheritance relationship. If we don't design well, it may expose some security hole. Okay, so that's for this session, and we will continue our discussion in our next session.